Hey everyone, and welcome. Today we're going to build out your essential Python tool belt. We're talking about mastering the core data collections that, trust me, you are going to use every single day as a programmer. So let's just dive right in.
So this is the big question, isn't it? Lists, tuples, dictionaries, strings. On the surface, they all seem to just hold data. But the thing is, they behave in fundamentally different ways. And getting this difference right, that's what separates a beginner from someone who writes really efficient, bug-free code. We're going to clear all that confusion up right now.
All right, here's our game plan. We'll start by dividing our tools into two big camps, the changemakers and the unchangeables. Then we'll see how to actually work with them, cover some pro tips to help you avoid common traps, and wrap it all up with a simple guide on how to choose the right tool for any job.
Okay, first up, the changemakers. These are your data types built for flexibility. I want you to think of them like a block of clay that you can just reshape whenever you want. This ability to be changed after it's created is called mutability, and it is an absolute game changer.
So meet the list. It's your go-to for pretty much any ordered sequence of items. And the key word here, the most important word, is changeable. You create one with square brackets, and you can throw anything in there. Numbers, strings, even other lists inside of lists. And this right here? This is a list superpower. Imagine you have a shopping list. You can add milk, you can change an item's position, or you can remove something you just bought. It's like a living, breathing collection of data that's always adapting to what you need it to do. Next up in our changemaker category is the dictionary. Now, instead of an ordered sequence, a dictionary stores data in what we call key value pairs. Just think of a real dictionary, right? You look up a word, that's the key, to find its definition, that's the value. And just like a list, it's totally mutable. So if you have a dictionary for, say, a user profile, you can easily update their email just by assigning a new value to the email key. You can add a totally new key like last_login, or just delete a pair you don't need anymore. They're designed from the ground up to be dynamic. Okay, so here's the bottom line for this section. Both lists and dictionaries are your changemakers. The main difference is just their structure. A list is an ordered sequence you access with a number, an index, while a dictionary is an unordered collection you access with a unique key. But they both share that all-important trait of being mutable. Now, let's flip the coin and look at the other side of our tool belt. Sometimes you absolutely do not want your data to change. For safety, for predictability, you need the unchangeables. And this whole concept is called immutability. And this is a tuple. At first glance, it looks almost exactly like a list. It's an ordered collection of items. But there are two huge differences. One, it's defined with parentheses, and two, it is fundamentally unchangeable. Once you create a tuple, that's it. Its contents are set in stone. And this just sums it up perfectly. If you try to change an item in a tuple, Python will literally stop everything and throw an error. Now, why is this a good thing? Well, it guarantees that your data stays constant. Think about something like coordinates for a screen resolution, like 1920, 1080. You really don't want those values accidentally changing. And the last tool in this group is the string. I know, we use them all the time for text, but it's really easy to forget their core nature. A string is an unchangeable or immutable sequence of characters. You can't just change a single character in the middle of a string. You have to create a whole new one. So, to wrap up this part, tuples and strings are our unchangeables. They give you reliability and make sure that data that's supposed to be constant, well, stays constant. Their shared key trait is immutability. Okay, so now we know our four data types. Let's look at something you can do with three of them, slicing. This is how you grab just a piece of a sequence. And there's one super simple rule you absolutely have to know. Just look at how consistent this is. When you slice a string, you get back a string. When you slice a list, you get back a list. The rule is incredibly simple, but so powerful. The type of the slice always matches the type of the original. This is a huge tip for exams, by the way. All right, time to get into some insider knowledge. These are the common mistakes and the safer practices that can trip up even experienced programmers. Think of this as leveling up your Python game. Let's kick things off with a classic exam-style question. You've got this dictionary, right? And you want to know if the value 100 exists anywhere inside it. Your first instinct might be to just use the in operator, but there's a catch. And here it is, the trap. For a list, the in operator checks the values, so you get true, just like you'd expect. But for a dictionary, in checks the
keys only. Since 100 is a value and not a key, the result is false. That is such a crucial distinction to remember. Here is another massive pro tip for working with dictionaries. If you try to access a key that doesn't exist using those square brackets, your whole program will just crash with a key error. The safer, professional way to do it is to use the .get method. If the key is missing, it simply returns none, and your program just keeps on running smoothly, no crash. And for our last tip, a little syntax gotcha that catches pretty much everyone at some point. When you type empty curly braces, like this, empty curly braces, you might think you're getting something generic, but nope, Python always gives you an empty dictionary. If you actually need something else, like an empty set, you have to explicitly ask for it with the set function. It's a really subtle point that can prevent some very confusing bugs down the road. So, we've met the changemakers and the unchangeables, we've learned some pro tips. Now let's bring it all home. How do you decide which one of these tools to pull from your tool belt for any specific task? This right here, this is your ultimate cheat sheet. So, you're going to use a list when you need a collection you know you're going to modify, like a to-do list. For data that must never ever change, like those screen coordinates, that is a job for a tuple. When you need to link unique identifiers to their values, like in a user profile, you'll reach for a dictionary. And of course, for any simple, unchangeable text, you've got the string. It really is that straightforward once you see it all laid out like this. So, there you have it. Your tool belt is now filled with 4 powerful, distinct tools. You know the difference between mutable and immutable, and you know exactly when to use each one. The only question left is, what are you going to build first?